Hello, everyone. In this episode, we'll talk about how to measure accuracy in these various predictions. I'll cover precision, recall, F1, RC, and AUC, area under curve. Okay, so for binary decisions, typically the easiest thing you can think of is confusion matrix. So here we put the predicted, so it's either innocent or guilty. We call the innocent negative and guilty positive. And also what in reality it is. So is it like guilty or innocent? So if the reality is guilty and we also predict guilty, that's the correct true positive. And if it's innocent and we predict to be innocent, that's correctly true negative. But there could be errors, isn't it? Like in reality, it's innocent, but we predict to be guilty. It's called type 1 error. It's called false positive. And the opposite case, where it's in reality guilty, but we predict to be innocent, is called type 2 error. It's false negative. And we can use a couple of ratios to measure how good our model is performing, but in the picture here. So in reality, this block here on this side is all guilty, and in this side is all innocent. And inside the circle is what we predict to be guilty or guilty. And what you can see is that on the negative, the innocent side here, there are a couple of which are in the circle, which are false positive. And on the truly guilty side, there are some in the circle. These are called true positive, isn't it? Yeah. So the precision is basically the ratio of the true positive. Okay, so here the true positive, which we predict to be positive, among the true positive and false positive, the true positive and false positive. So among all those we tag to be guilty, the one that are really guilty is the precision. And the recall is the true positive divided by true positive plus false negative, which is among all the really guilty, how many do we tag to be guilty, all right? So this is called recall. And there's a trade-off in that you cannot make the precision and recall both be increasing, isn't it? For example, if you identify a single individual correctly as guilty, the precision will be 1.0 and no false positive, but recall will be very low because we'll still have many false negatives. You see the point here? Yeah. But if we label everyone as guilty, of course, then our recall is perfect, but the precision will be fairly low. It's fairly obvious, isn't it? And if you label no one as guilty and has zero precision and zero recall, because there are no true positives. And the F1 scores combined basically because you cannot get both precision and recall be great. So, and one can manipulate one number to be extremely good and the other one terrible. So we sometimes use the harmonic mean like this. It's called the F1 score. Also, to visualize it, this is called the receiver operating characteristics. It came from the radar engineers a long time ago. What is plotted here is that in the box, the false positive rate, which I think it's better to have a zero false positive rate. You don't accuse the innocent. And the true positive rate, which you like to be 1, isn't it? So being in this corner is ideally the best, okay? And as you increase the threshold of tagging, meaning you make the circle bigger and bigger, what will happen is that here in the low threshold, it's basically making the circle really big. So you tag everyone as guilty. As you increase the threshold of accusing guilty, and if you can be as extreme that you label no one to be guilty. So here, your model will be basically, ideally, you hope it to be going like this, but in reality, it will go draw a curve like this, and you will probably pick a threshold, meaning draw the size of the circle to tag people guilty somewhere here so that it has a reasonably low false positive and high true positive rate, right? Yeah. So enough with the theory. Let me go on, share the code, and let's go look a sample here. So here is just the example. So it's a classification. So you have 2 classes and 2,000 samples. So here's the data. And if you check the dimension of the data, there are 2,000 of the dimension. There are 20 predictors, and the Y is 1, 0. That guilty or not, and then split into train and test set. Okay, and then generate just randomly class and fit a logit model. And how does and do the predict, the logit predicts, okay? And to keep the probabilities of positive outcome only, right? Now the ROC curve, so how to use the program is that, well, you calculate the scores, ROC AUC score, which is here, you can see area under curve and receiver operating characteristics of the no-skill and the logit. You can compare that and summarize the score of how many there are. The no-skill is 0.5, like it's random guess, whereas the logistic function actually gets them right, 96, 97%. So you can see that it's fairly skillful, of course. And then ROC curve, no skill, and false and true positive rates. Once you get those kind of all this numbers of the false positive rate or true positive rate, now you can plot the area under curve of the ROC curve here, which basically gets you some picture like this. And you probably want to pick a threshold that's something looking like this here. Okay. So, and the precision and recall curve, okay. So now you have the logit, area under curve, and then do this. What you can see is that the precision and the recall basically has a trade-off. See that here? You can have high precision, but then the recall is low, and as you go here, and you probably want to pick something where recall and precisions are reasonably high, okay? Yeah. All right, so this was just getting through basic definitions of recall, precision, and various accuracy measures. Thank you for watching this episode.